This is video 3 for lesson 2 of unit 9, weak acids and bases. So we're going to continue our look at different types of example problems in working with weak acids and bases. So here we're given another acid. This time it's chloroacetic acid. Again, we can just use HA, but we're given a pH. And this right here is our original or our initial concentration of HA, 0.115 molar. We want to calculate Ka and percent ionization. My fingers must not have hit the shift key. So it's not 5 ionization, it's percent ionization. So if we're given a pH, we can use our pH equations to calculate our value of H3O+. So we know that the concentration of H3O+ is equal to 10 to the negative pH. So we can put in 10 to the negative 1.92, and we're going to get 0.0120 molar H3O+. So there is our value for H3O+ in our ice chart. So we're just going to use a generic equation. Make our ice chart. So I know that this was 0.115. Those two are 0. And I know what this value is here. It's 0.0120, which means that our A minus is also that. So these are our values. It originally was 0, so these must be plus 0.0120. And this has to be minus 0.0120. All I have to do is subtract that, and I get 0.103. Here are the three values that we're going to use in our Ka calculations. So Ka is going to be 0.0120 times 0.0120 all over 0.103, which gives us a Ka of 1.40 times 10 to the minus third. So right there is one of our answers. And percent ionization. Well, if you recall, it's how much H3O+ forms from our original HA amount times 100. So 0.0120 over 0.115 times 100. And that gives us 10.4% ionized. There is our answer. Moving on to problem number 4. Now we get a little bit more complicated. So we want to find concentrations if we're given a Ka. If you weren't given a Ka, you might have to look up the value on our Ka-Kb chart. So we're given a 0.100 molar solution of HClO3. We're given a Ka value. Calculate the concentrations of all species and the pH of the solution. So again, we don't know how much of this ionizes. So we can't just calculate the pH from that. We have to know what the concentration of H3O+. This is not strong, and it doesn't fully ionize. So with this, now we have to do a formal ice chart with our X values in it. So HA would be the HClO, A minus would be ClO minus. So we set up our ice chart and we know that we have that much HA. That's it. These are both 0. And we know that this is going to go down by a factor of X, and these are going to go up by a factor of X. So at equilibrium, here are our values. So when we calculate Ka, or the concentrations, we use our Ka, which is 3.450 times 10 to the minus 8. And that is equal to x times x all over 0.100 minus x. But if you notice, this and this are really, really different. There's a huge number of significant figures between these two. In fact, this value is so small that it would not impact this value of x, or value 0.100 minus x all that much. So we're going to make an assumption. If Ka and HA's concentration, so this value right here and this value right here, are 4 or more decimal place values apart. Drop the minus x from the denominator. Otherwise, use the quadratic formula. So this right here, 0.1 is to the 10th place. So times 10 to the negative first. This is times 10 to the negative 8th. So there's way more than 4 decimal place values between this value, the 0.1, and this value, which is 0.70 and then 350. So what we do is we circle it and write assume. Please don't abbreviate assume. And then we can solve this easily now without having to use the quadratic formula. So we multiply both sides by 0.1 and then take the square root of both sides, and we get x is equal to 5.92 times 10 to the negative 5th. We need this value to calculate H3O plus and A minus and eventually the pH. But as you can see, this x value, when we put this back in here, this is not big enough to be significant, and we do not end up with a change in HA. So HA is 0.100 molar. So little of it ionized that it's not significant. But H3O plus, 5.92 times 10 to the negative 5th molar, A minus, they're the same thing. And then we can calculate pH by taking the negative log of 5.92 times 10 to the minus 5th, and we get 4.23. There are the answers.